Now let's work through the discovering distance activity in order to learn the formula for the length of a line segment. The first question asks, how long is the line segment on the graph? So let's just count the squares. We can see that it's 5 units tall, so let's press 5, submit. Correct. How can the length be determined using a mathematical calculation instead of counting the number of squares? We could simply take its y-coordinate at this end, which is 8, subtract its y-coordinate at this end, which is 3. 8 minus 3 equals 5. So let's practice subtracting y-coordinates. Question 1 asks us to take y2, subtract y1. So we'll take y2, which is 6, subtract y1, which is 5. Question 2, y2 is 7, subtract y1, which is 5. In question 3, y2 is 8, y1 is 7. In question 4, y2 is 9, and y1 is 5. We press submit. Now we're asked to calculate the length. So 6 take away 5 is 1, 7 take away 5 is 2, 8 take away 7 is 1, 9 take away 5 is 4. Our answers are correct, so it's allowing us to continue. Now we're going to look at horizontal line segments. This segment we can see from counting the squares is 6 units long. Again, we simply take the x-coordinate at this end, which is 8, and subtract the x-coordinate at this end, which is 2. 8, take away 2, length is 6. So now let's practice with horizontal line segments. Plug in x2, which is 9, x1 is 7. x2 is 9, x1 is 7, x2 is 8, x1 is 7, x2 is 9, x1 is 8. Now we'll do the subtraction. 9 take away 7 is 2, 9 take away 7 is 2, 8 take away 7 is 1, 9 take away 8 is 1. So now we're looking at diagonal line segments. We can't simply count squares. What we're going to do is combine the concept for horizontal segment length and vertical segment length. So you'll notice any diagonal can be turned into a right angle triangle by adding the vertical and horizontal components. So let's fill in the calculation to calculate the length of each component. First we'll do the vertical. So y2 is 5. Take away y1, which is 2, giving us a length of 3. Now we're going to do the horizontal segment. x2 is 7 and x1 is 3. So 7 take away 3, our length is 4. So now we know that our y length is 4 and our x length is 3. Now let's use the Pythagorean theorem in order to calculate the length of the diagonal. So we know our basic Pythagorean formula is c squared equals a squared plus b squared. So first let's plug in a, that's the length of one of our sides, so we'll choose 4, plus b is the length of another one of our shorter sides, so that'll be 3. Now we need to square each value. So 4 squared is 16. 3 squared is 9. Now we're asked to add them up. 16 plus 9 is 25. Now to get c by itself from c squared, we're going to take the square root of both sides. So we'll take the square root of 25. Which gives us an answer of 5, since we're only interested in the positive square root since we're concerned with length. Now we'll continue and look at how the question started. If we go back to this step, c squared equals 4 squared plus 3 squared, we see that we got 4 from taking 7 minus 3, and 3 from taking 5 minus 2. Those were x2 minus x1 and y2 minus y1. So now we've expanded the Pythagorean formula into this slightly longer formula that concerns itself with our line segments. So instead of c, if we call this length, because this is the length of our line segment, length squared is equal to x2 minus x1 squared plus y2 minus y1 squared. So to get length by itself, we simply take the square root of both sides. Now we have the formula for length of a line segment. So length is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So now let's practice with a few examples. We're going to fill in the blanks again using the coordinates given. Here's our formula. So we'll start with x2, which is negative 4, minus x1, which is 8, y2 is 5, y1 is 3. Doing the math inside the brackets, negative 4 minus 8 is a negative 12. 5 minus 3 is 2. Negative 12 squared is 144. 2 squared is 4. We can add those together. We get 148. Now we need to take the square root of 148, so let's use our calculator. So using our calculator, we'll type in 148 and then press the square root key, giving us an answer of 12.165. So let's type in an answer of 12.2, rounding to 1 decimal place. And we see that we have the correct answer. Second example, our x2 coordinate is 6, x1 is negative 10, y2 is 5, y1 is 8. 6 minus negative 10, that's 6 plus 10, 16. 5 minus 8 is negative 3. 16 squared. We can use our calculator for this if you don't know it. So 16, then press the squared key, 256. Negative 3 squared is 9. Adding those together, 256 plus 9 is 265. Now we need to take the square root. Again, just type in 265 and press the square root key, giving us an answer of 16.2788. If we round to 1 decimal place, the 7 makes 2 go to 3, so our answer will be 16.3.